All right, my name is Paul Schuster. I am a climate change scientist, retired from the U.S. Geological Survey, um, and um, and I spend my spare time doing these kinds of presentations. So, welcome everybody. Um, I'm based in Denver, Colorado, in a snowstorm currently going right now. Um, so let's get going here. Some of these slides may be familiar to some other people that when I gave previous presentations for the Climate Reality Project. So uh, I I always start out talking about my perspective is from a big picture. So I don't tend to discuss local and regional climate change issues. It's more of looking at it from a world point of view. So anyway, and this presentation is going to be more fun and entertaining than in science. I'm folding in a lot of personal stories that have happened to me during my career, my 36 years of doing this. Which you can imagine doing anything for 36 years. Everybody's got stories to tell. So that's kind of the premise for this presentation. So let's get going here. This is the Alcan Highway, and it goes through Canada, and it's in big trouble. It's got a lot of permafrost, what they call frost heaving, as you can see in the photo there. So that's one of the biggest concerns about climate change is the falling permafrost in the world and northern hemisphere. So there's a direct result of climate changes. You're looking at that road right there. That's a rough road to travel on. Believe me, I've done it a couple times, and it gets worse and worse every time I go. It's more and more frost heaves. It's in bad shape. So, and then there's what they call reef photography here. This is a then and now for a glacier, the Mendenhall, which is near Juneau, Alaska. And I don't even need to tell you that speaks for itself. So anyway, this is more recent. This, I'll tell you what, in the north, it is getting so real in terms of the impacts of climate change that the Department of Interior now has a relocation program for Inuits and natives and communities throughout northern Alaska, because they have to move. It's getting so bad that from the effects of climate change that they literally have to relocate. So, and this is a poster for a presentation that was given, I believe, in Fairbanks, about discussing what we're going to do about this. So it's getting really real. And the people that live down in the lower 48 just don't seem to get it right now. So I just have to quickly do this one. I've done this before with you guys. This is like my disclaimer. So, being that I'm still represent the USGS, I kind of have to put this up. But it's just formality. So I'm gonna blast through this one. So I know some of you I've talked to some of you before about the Keeling curve, and that, to me, that's the like the heartbeat of the whole of all the concerns of climate change. It's basically monitoring the amount of carbon dioxide in the atmosphere, the concentrations. And since I last talked to you guys, we've gone up from about 404 parts per million to 414 since the last time I talked to you. It's going up not at a linear rate, but at an exponential rate. These are big concerns for climate scientists, because we really concentrate on extrapolation, and we use extrapolation for predictions, and the predictions aren't good as long as we keep continuing these trends. There's been a 50% increase in carbon dioxide since 1960. And that's pretty much off the charts when you look at the geologic record. And our big concern is what they call the runaway greenhouse effect, where we're going to get to a point where they think it's around 500 parts per million. We're at 414 right now, where we can no longer control the greenhouse effect. And not to be an alarmist, but it is a fact that Venus is a runaway greenhouse effect, and the temperatures on Venus can melt lead at the surface. So we don't want to go there, and we need to make some big decisions as humanity, as humans, to curtail the continued pumping of carbon dioxide into the atmosphere. Okay, so I'm a scientist, and we all follow the scientific process. Something that's unique about my career is that I was able to follow it from the beginning to the end. And so this outlines what you typically do as a scientist. You develop a hypothesis. Basically, it's always a question. What is your question? So you start with the question, you collect data that, to basically hopefully answer that question, which involves field work and lab work. And then you do experimentation, and this is part of the scientific process. You need to reproduce your results. You need to make sure that your calibrations are quality assured. And then with all that done, then you report all this. You interpret it, and you have your conclusions. But then the most important part of this entire process is the scientific peer review. You need to have the rest of your peers review and critique your work. Without that part of it, it doesn't mean anything. It has no water to hold. So I always stress the fact that anything you read must be scientifically peer reviewed if you want to take that literature seriously. In other words, don't read the newspaper when you really want to have get a scientific view. Don't listen to Facebook. Don't listen, all these other medias that are out there. It's the scientific peer review process that's the most important. So, and this can take a while too, and that's why it's so effective. I've had papers where the review process lasted more than a year before they finally okayed it. They finally criticized it to the point where it was good science. So, but then we all go into the unknown, and that's the politics and policy that take all this scientific data and they do what they do with it, and that's a whole different story. So this is where I basically have done a lot of my research in related to climate change. So I've been around. I've been all the way to the end. Oh, sorry. Hey guys, stop. Sorry. So I've been all the way up to Anchorage and all the way down to Miami, or down to the southern part of Florida. So I've really covered a lot of range, in a lot of land in my research, and I'm going to go through maybe about 6-7 studies that I've been involved in, and this is a list of them right here, and I'm going to get going here with each of these studies. So they're kind of, I categorize them. So we have what we call monitoring or baseline studies, where we're just trying to get a baseline of what the conditions are now, so that we can measure against changes in the future. And then we have what we call environmental impact studies, where we've done things to the land, big things like put in giant dams, or extracted huge amounts of groundwater, and or just reconfigured the hydrology of certain ecosystems, like in the Everglades. These are man-made problems, and they're big problems. So we call them EIS studies, or EISs. You might have heard that term before. So And then we get into really true kind of climate change studies that I've been involved in. And with climate change studies, you want to look into the past to understand the future. And we have places to go to answer those kinds of questions. Glaciers are a great information source for the past. They're like a book, and each time it snows on a glacier, that's a chapter in a book. And so we've done work where we've extracted cores from glaciers to reconstruct paleoclimates, paleo-environmental conditions. And then and we have that again on the Yukon River. We have a big river system that is basically pristine right now, but it's changing right now because of the rapid changes in climate and warming trends in the north. And also permafrost has been kind of what the underestimated effects of climate change on permafrost. And we're just now learning the big impacts of the thawing permafrost. So I was involved in a Western Lake survey on these alpine lakes across the western part of the country. And this is a baseline study. We wanted to get out there before things really started to change. So we got our hiking boots on and we went up into the alpine areas and with our equipment, and we did a lot of monitoring of over 100 lakes, I believe it was. And then we reported that information, and it's archived, and we use it now as a baseline because things now are changing, and they're changing fast. All these alpine environments are very, very sensitive to changes, to minor changes. So we do that, and during one of our expeditions, we were sitting down and eating our dinner, and that's a photo of my colleague there, because in the background, all the trees started ruffling. Like really, there was something out there, and whatever it was really big. And we kind of assumed it was a bear, but we just kind of let the critter do what it was going to do, and it did go away. And but that night when we were in our tent, it came back, and came right up against our tent and actually rubbed against our tent. And I'll tell you what, I was never so scared in my life. I literally froze from fear because I thought this giant creature was just going to rip the tent open, but it didn't. It just sniffed around, went away. So anyway, that was my first taste of one of many accounts with bears. So another study is that I was on was in the high regions of southern Colorado, where we did a long-term study. Again, this is considered baseline or monitoring study, and it was basically to try to understand cycles in the climate. And we did conclude that there is a 25-year drought cycle in southern Colorado. So while we were out there, not in the winter like in these pictures, but in the summer, we were sampling the streams there, and I was going through some like reeds close to the creek, and all of a sudden, out of the creek rose up and right in front of me, this giant moose. And I don't know if anybody's ever seen a moose, but they can get really big. And I mean, I'm telling you, like almost the size of a small elephant. And they get tall. And this moose just kept just rising and rising up out of the creek because it was a hot summer day. He was just bedding down to get cool, but I disturbed him. And that's the last thing you want to do is come up on a moose like that. But I didn't see him because of the reeds. So I startled him, he startled me, and I had a big backpack on full of water samples. And I just literally fell over on my back. And I was like a turtle that had flipped over that could not get back up again. I'm thinking, oh, this is it, I'm done, because what moose do is they trample you. That's pretty much how they kill their threats. And I thought, oh, he's just going to come over and stomp me to death. But he didn't. He turned around and he just went right back up the ridge, and I never saw him again. So I got lucky on that one. One of the best studies I've been on, one of the most fun studies I've been on, is the Grand Canyon Dam release studies back in the early '90s, where we were trying to understand what we had done to the environment after we put the dams in, the Glen Canyon Dam and the Hoover Dam. When they put those dams in, they really weren't concerned about environmental impacts. But later on, decades and decades later, they did become concerned. So we did a lot of studies that tried to determine what the impacts of the dams were on the ecosystem, and the flora and fauna of the ecosystem. So we spent a lot of time down there, camping, sampling, collecting our data in the field, and we came across some pretty interesting fauna. That scorpion you see there it looks more like a lobster. So the outfitters that took us down there, one of the outfitters found this scorpion in his sleeping bag before he got in. And one of the biggest rules of being down there is you always check your bag before you climb into it. And he did, and he found this thing and shook it out. And he put it in this pot. He showed it to all this. This guy had been working down the Grand Canyon for 30 years, and he said he had never seen a scorpion this big. So it's kind of a testament to how big that scorpion actually is. And then I had a friend, a colleague of mine, who didn't check his bag, and it wasn't a scorpion that bit him. It was a brown recluse spider, and we have a name for this story because, unfortunately, if anyone knows what brown recluses do, when they bite you, they have a bacteria that gets into your skin, and it's a flesh-eating bacteria, and it can cause necrosis, and basically it kills your tissue. He ended up losing half of his butt. And now later on, years and years later, we always tease him, telling him that he does everything half-assed. So that's a kind of a funny story. And he's okay now, by the way. All right, so a lot of my threats in my career have not been from natural wildlife, and some of the most terrifying threats, unfortunately, are from my fellow man. So this was a study we were on down in the Las Vegas basin, where we were looking at the withdrawal of groundwater and the effects of the withdrawal. And you can see that that as you withdraw groundwater from the ground subsides, it sinks. And this is a common thing that happens in a lot of places, but in the Las Vegas basin, it's really dramatic, and you can see it in a lot of places. So we were trying to kind of model the drawdown and see the effects it was going to have on infrastructure, anything from infrastructure to just basic supply of groundwater. So while we were out there, I was sitting by one of the wells, measuring some parameters, and I heard these pings on the truck. I look up and I saw holes, and I was like, what in the world? And then again, two more ping ping, and I'm like, oh my God, somebody's shooting at us. And sure enough, it was from near one of the apartment developments. Someone was literally shooting a rifle at us, and so that then we packed up and drove out of there right away. And then I got to just tell this story. I had a lot of students that worked for me, and I would always assign them the job of taking field notes down while we were working. Like what the weather is and the conditions around the area. The basic field, scientific field notes. And one of my students had a sense of humor, and we were in the median of a highway taking some samples, and it was right near downtown Las Vegas, and during the summer, and it was really hot that day, and so she recorded the weather, and in the place for temperature, she wrote hotter than the hooker across the street. And I still, that resonates with me every time I look at the Las Vegas study stuff. I think about that quote that she put in my field notebook. So that's some comedy in there. So uh, uh, another really fascinating study I've been on is in the Everglades of Florida. And again, this is an ecosystem environmental impact study. It was the effects of agriculture on the ecosystem, the hydrology of the Everglades, which is a very fragile system. Unfortunately, we've really impacted the Everglades so much over the last 100 some years that it's never going to be the same again. More the way we're looking at it now is how do we remediate? How do we manage the system to try to at least get it somewhere back to where it used to be? It'll never be back to what it used to be, but we're trying. And there's been some major, based on our studies, there's been some major improvements in the management of the Everglades. So while we were down there, you can see to the left over there that those are not logs; those are alligators in that pond there, and they're everywhere. I'll tell you, every place you turn around, they seem to be just hiding in the reeds and in the mud, and they want you. They leave you alone. They don't want to be disturbed. They don't want to make a ruckus around you unless you really antagonize them. We were down there on a floating dock one day, and we had to wear these Tyvek suits, which were very uncomfortable and hot. But the people I was with, they had like a boom box, a stereo player, so that we just had some music to go by while we were working. And somebody had it, this was in the 90s, so they had these mixed tapes that people used to like to listen to, and one of them put a tape in, and it was just mixed artists, and so scientists tend to recognize patterns. So every time a Stevie Ray Vaughan song came on, the alligators would come right up to the dock, and they just come up and just look at us. And then when the Stevie Ray Vaughan song was done, they'd go away. And then we thought, well, that was just a fluke, But then it happened again and again and again. And so I'm convinced that alligators love Stevie Ray Vaughan for some reason. We always thought that was hilarious, and we even tested it, with other people later on. Like, said, you want to see something interesting? Watch this, and we'd put a Stevie Ray Vaughan song on, and the alligators would come crawling up to the dock. So again, another really funny story in the field. So one of the most interesting studies I've been on is in the glaciers of Wyoming, where we reconstructed paleoclimates. And that was some of the hardest work I ever did. I lived on a glacier twice for at least a month. And there's just certain things you'd never expect about, living on a glacier. One of them is, where do you go to the bathroom? Where's your latrine, and what do you do about that? You don't want 20 guys and women peeing all over the glacier, so you have to control it in a way. So we set up our latrine. So we had our drill hole and we had our pee hole, and we said everybody's got to go in that hole, that one hole, not everywhere around the glacier. That's going to make a mess. So anyway, something that you would never thought of, when you go up to work on a glacier. But again, there's certain kind of just living management things that issues you have to deal with. So, and there've been some pretty unique experiences. Um, I think my favorite story that I have about working in the wild in my 36 years is we used goats to get our equipment to and from the glacier, because goats, they do much better than horses. Horses could never travel on that terrain you're seeing there over the glaciers and the rocks. Um, so we hired a goat man who rose what they called wethers. These are specially engineered goats for carrying stuff, and they can get really big. One of the biggest goats I'd ever seen in my life was Alpy, who was here in this photo. Alpy, at eye to eye, was taller than me, and I'm 5'5", so he looked down at me. That's how big Alpy was, and he could carry 200 pounds. And I called him the super goat. Well, Alpy actually saved our lives, and I would not be here if it wasn't for this goat. So we're going across a talus slope on the way to the glacier, and it was summertime, and the rocks were getting loose from all the melting snow and ice around them. And it's very common to have rock slides at that time of year. And we're traversing across this talus slope with Alpy in the front. He was the lead goat. No one went before Alpy. No other goat went before Alpy, and he was in charge. And he stopped in the middle of this talus slope, and we couldn't get him to go. And all the other goats, 14 goats behind him, stopped, and we could not. The goat man could not pull him. He would not move. And we're like, so we're just sitting there waiting for Alpy to start going again. And then up ahead, about 500 yards, maybe 300 yards up ahead, a giant rock slide came down, and it was the boulders the size of Volkswagens. And if Alpy had not stopped, we would have been right where that rock slide came down. Somehow this goat knew that thing was going to go. And it still chokes me up to this day, because if he had not stopped, well, I would not be here. So I owe my life to a goat, believe it or not. So yet another good tale from the wild. My latest study before I retired was the Yukon River study, where I've been working in the Yukon now off and on for 20 years. And the Yukon, if anyone hasn't been in the Yukon basin and in the bush of Alaska, as they call it, it's like going back in time. And it's strange because they have cell phones and they have all the technology, but yet many people live in huts and cabins that don't even they have dirt floors or no running water. So it's kind of a dichotomy. It's a clash of third world and first world. And so we were gassing up one day at Fort Yukon. And Fort Yukon is a rough town. They say it's like the old Wild West, but in the north. And running the gas station was this character. I'll never forget this guy. His name was Trader Dan, and he ran the only gas station for like 100 miles. And so we're filling up our tanks for our boats, and I just got to talking to Trader Dan. And I said, so how's the climate been around here? Because he lived there all his life, like for 50 some years. And he had a really rough voice from smoking cigarettes all his life. And in his rough voice, he said, well, it just doesn't get cold around here like it used to. We don't get those minus 70-degree weeks anymore. And it's not like it used to be. And I said, oh yeah, that sounds really interesting. He says, and yeah, the last time this happened was like maybe 10 years ago. And we all knew it was going to happen. We all knew the big cold front was going to come in, and we were going to, and so we all started preparing. We were getting our kerosene tanks ready for our all our heaters in our homes, and he said, and I had a tank out in front of my house, and it froze to the ground, and a couple of days later, these kids came by and they tried to steal my tank, but they couldn't get it out of the ground. And they kept banging on it and banging on it. And every day they'd come by and bang on it and try to get it loose. And then he said, like in a heartbeat, without skipping a beat, he said, so I got tired of all that banging. So I just went out and I shot him. and I was like, what, Trader Dan? What'd you do? You shot them? He said, yeah, I shot him. So it's a rough town, and Trader Dan wasn't going to take any crap. So anyway, you meet some really legitimate characters out in the Yukon. So I'm getting to the end here. I went a lot quicker than I thought it would. Today is for today, every day I wake up, I think of children, and I think of I have grandchildren, and I just think of the things we've done, our generations have done, and how the future generations are going to have to react and somehow remediate what we've done. And all through my career, I've come across so many kids and the youth that and I'll tell you, they're so positive. I'm kind of burnt. I'm not as positive as the children are and the youth. They're going to go for this. They're going to fix this planet, and I have confidence in that. And I see it all the time when I go out in the field. I see the enthusiasm of the youth just wanting to learn and know about climate and about the way the earth works, and I'm actually optimistic. So that's it. I don't know how long this lasted, but I hope that the recording went well, and that I always like to answer questions. I'm always there by email. I still have a USGS account. I should have put it up in this slideshow, but maybe Smito or Tracy could somehow insert my information into this presentation, so that anyone that has questions can answer. Can contact me and I'll give them my answers. USGS used to have a program called Ask a Geologist, and I was involved in that, and it was like a rotational thing. So every 6 weeks I would get questions from all over the world, any kind of subject. Some pretty amazing questions too. The question I always remember was that a kid from a fourth grader from Indiana, I think, somewhere in the Midwest. His question was, are there more stars in the universe than grains of sand on our planet? And so me and a colleague, and I thought, how do you answer that question? So me and a colleague got down to business, and we made a lot of assumptions. And we actually came to the conclusion that, believe it or not, there's more stars in the universe than there are grains of sand. So and that's one of the fun things about being a scientist, is that you may have a hypothesis and you may have some predetermined answers to your questions, but when you find out it's not what you get surprised that it's not what you thought it was. And I think that's one of the most exciting things about being a scientist. So good luck with everything. And I think that's about the end of my presentation. And thank you for listening.
Hey, thank you so much, Paul. This was a wonderful, eye-opening presentation on the life of a climate scientist. Not without its perils, it seems.
Yeah.
Tracy, do you have any questions for Paul?
I did have a question, but you may have answered it. When you started in the beginning, you said you start with a question as far as, doing research. Do do you have an idea of the answer, or is it just completely a blank slate? So are you trying to prove what you think is right, or are you trying to prove what you think
Right.
is wrong, or you just want an answer?
That's a good observation. Uh, what part of that is the hypothesis? So when I say we come up with a question, tied to that is the hypothesis of what you think the answer might be. So that's what they mean. Whenever you hear the term hypothesis, that's where they're driving towards. But we try not to be, we try to be so totally objective about our approaches and not subjective. And that's a challenge sometimes, you know. Sometimes scientists go into these predetermined answers, but that's where you got to be real careful, and you got to really concentrate on following the scientific process or the scientific method. And so, unfortunately, some scientists don't do that. So, that they're a rare breed. So that's a good question, though, Tracy.
Thank you, and I love Alpi. I'm thankful for Alpi. That's a great story.
Yeah, and I did. There's another part to that story. Alpi was he saved my life, yes, but he wasn't very personable. One of the other goats, his name was Menu. His name was Menu, and Menu was smaller, and he always wanted to get into my tent and sleep with me, and I just couldn't get, you know, he's, even though he was smaller, he was still big. So I didn't have enough room in my tent. Yeah. But his name was Menu because on one of the goat man who owned all the goats, on one of his expeditions, he got snowed in, and he ran out of food, and Menu was literally on the menu. So
oh no.
But the snowstorm broke, and they were able to get out, and Menu had a new name. You know, he now he had his name, so, and it stuck.
That's great. That's great. All right, I have one more, and then I will let you go. I am originally from Fort Lauderdale, Florida, so the Everglades are near and dear to my heart, as are reptiles. But why did you have to wear Tyvek suits? Why?
Very good question. Because we were doing sampling for heavy metals, and like things like mercury and cobalt. There's a whole list of them, and they're at very, very low concentrations in the environment, even though they're deadly. Okay, so humans are actually, everyone thinks that we're wearing the suits to protect ourselves from the environment. It's the other way around. We were wearing our suits to not contaminate what we were sampling. because we're dirty. Okay.
I see. Yeah. Thank you. It was fabulous. I loved it. Thanks, Paul.
I'm sorry.
Paul. Thank you so much.
Okay.
I think we'll end this recording, and we'll share it with our team and anyone else that's interested.